Okay, hello everyone. Welcome back to recitation number 3. So today we have two big ideas we want to focus on, the regular expressions and how to convert from an NFA to a DFA. So there are some really cool ideas we can learn here. But before that, let's just go real quickly on this last week's exercise. So if you remember last week, we ended on this notion or this exercise where you had to create an NFA. So hopefully you try to solve it on your own. I'm gonna just try real quickly to show you the solution. But a reminder, we were trying to make an NFA for all binary strings. So our alphabet was just zeros and ones. And we cared about these conditions. Either the number of zeros should be multiple of 3, or the number of ones should not be a multiple of 3, or if both conditions are true at the same time, that's okay. So the idea that we had to do last time is as follows. So we begin with the start state, and I know we could have done a DFA for this and we would have gotten maybe 9 states, but really the purpose of this exercise was to use the flexibility of NFAs. And an idea that you could do in this scenario is sort of like dividing and conquering. So first, I'll try to take care of the condition of zeros. Okay, so I'll make an epsilon transition here. And in this part, I'll just focus on the first condition. And like if you only focus on the blue, we've done a DFA for that before, like multiple of zeros, a multiple of 3 for zeros. Well, that just gives, I just need 3 states for that. I'll call them 3k0, like multiple of 3 for the number 0. That's just a name. You can name it whatever you want. 3k0 plus 1 and 3k0 plus 2. Like it's either a multiple of 3 or it has a remainder 1, it has a remainder 2. We've done this before. And now since all I care about is just the zeros, what I can do is, well, I'm here. If I read a 0, we go here. If I read a 0 here, and a 0 here. Kind of like a looping. And since I only care about the 0, if I read a 1, I'll just loop back on myself. That's fine for each case. Why am I doing this? I only care now about checking if the 0 is a multiple of 3 or not. And since I want it to be a multiple of 3, I'll make the accepting state the 3k0. We're done with the first condition. Now we can work on the other one or on the orange condition. Again, an epsilon transition here. It's the same DFA, but the difference is you don't want it to be a multiple of 3, and what you don't want is the number of ones. So again, very similar, I'll say 3k1. So this time I'm focusing on the ones. Is the 1 a multiple of 3? Or does it have a remainder 1? Or does it have a remainder 2? And since it's very close or very similar, we still have this sort of circular motion when I'm reading ones. The difference is now on the 0, I'll loop back on myself because I'm focusing now on the 1. Also, the difference is maybe the accepting states. Can anybody guess what will my accepting states be here? For the orange part? What do you think? Number of 1 is not a multiple of 3.
3k plus 2 with 3k plus 1.
Exactly. If 3k means multiple of 3, well, I don't want that. The other ones are what I want, so I'll just circle them so they kind of look like accepting states. You could have done the accepting state right away while you were drawing if you already knew ahead of time, but this is okay. And technically, I'm done. Yes, exactly, Nagam. It's those two. This is all we really need. It's only 7 states, and if you really focus on it, the important ones are these, even though the start state is very, very important. It's the kicker. This kind of solves the original question. Why? Let's just go through some, well, cases. There are 4 possible cases a string could come in. So let's go through them. The first case, it could satisfy the blue condition, but not the orange. So I get something like, say, 0, 0, 1, 0, 1, 1. This satisfies the first but not the other. Why? The 0 is a multiple of 3. The 1 is a multiple of 3, which doesn't satisfy the orange, but the blue is satisfied. So what happens in this case? Remember, an NFA, there are branches. There are multiple routes we can take, not just one. And since at the start state is already the fork in our NFA, I can either go up or I can go down. If I go up to the blue part, what does the blue do? It checks if the 0 is multiple of 3. So if it goes up, it gets accepted, which is correct. That's for the first case. The second case, it satisfies the orange condition, but not the blue. So something like 0, 0, 1, 1. This doesn't satisfy blue, but satisfies the orange. So what happens here? Well, say I first go to the upstairs, the blue machine, it checks, am I a multiple of 3, 0? No, so that branch gets rejected. But with NFAs, if only one branch get accepted, that's enough for me. So now I try the other route. I go down with the orange. Do I have a multiple of 3? Do I not have a multiple of 3 ones? Yes, I don't, so I accept. Basically, the route that we take is this. 3K1. So with the epsilon, I go here. Then I loop on myself twice as I'm reading the 1. Then, as I'm reading the 0. Then when I read the 1, I go 3K plus 1. Then I go 3K plus 2, which is an accepting state, so I accept. So again, the first branch didn't work, but the second one did, so we accept. Third case, what if both conditions are satisfied? So what if I have something like 0, 0, 1, 1, 0? So multiple of 3 zeros and not multiple of 3 ones. That's also okay. That's also okay. Fatima, what if the branch accepted, what happens? Does it check the second? No, right away it stops, Fatima. Because remember, with the branching, if one is accepted, you accept. So if you reach a branch that it's accepting, there's no need to continue. Like you break your loop, you stop your program, you already accepted. There's no need to keep checking. Now with this third
I have
case, Mhm.
uh, I
Yes,
have a
Maryam.
question. Sorry. إذا كانت and بدل ال or, what can we do؟
What do you mean and both? Uh,
يعني number of zeros is a multiple of 3 and the number of ones is not a multiple of
Oh, well, that's a different question. You want both of them to be true at the same time. So this solution would not work. We'd have to think of something else. Maybe then the DFA where we have 9 big states, maybe that's the only solution. So we'd have to think about it. But definitely this will not work because right now we're splitting our priority. Blue takes care of only 0, orange takes care of only 1. What you're saying won't work here because if I enter the blue machine, I'm only checking if I have a multiple of zeros. I'm not checking about the 1. Like if you notice, I'm looping on myself with the 1, which means I don't care about it. Nagam, can we take the negation? Not A or B is not A and not B. Maybe there's something there. Maybe there's something there. We'd have to think it. But in terms of how the machine will look, I'm not sure if it'll be as simple as just flipping the states. But yeah, so again, back to part 3, or the third case. This satisfies both conditions, yes? And since I'm saying or both are true, that's okay. What will happen? I'll go to the blue part. I'll check, is the 0 multiple? Yes, I accept right away. I don't need to go down. If I go down and check, it's also going to be true, but I don't need to go down. 1 is enough. Finally, the fourth case, what if both conditions don't satisfy it? So 0, 0, 1, 1, 1. This ruins both conditions. Does it get rejected? What happens? I go upstairs. Is there a multiple of 3, 0? No, so that branch doesn't work. I go down. Is there not a multiple of 3 ones? Also, no, I do have a multiple of 3, so I also reject. All the branches don't work, so I reject this one. Okay. So basically the 4 general cases, and I think maybe the 4 only cases, they all work. But as I think maybe Maryam was asking, if it was an and, it would have been different. And also, if this was, so this is basically right now an inclusive or. So if both conditions are true at the same time, it's okay. But if both conditions shouldn't be at the same time, like if we had said or and not both, if not both, it would have been a different story. Again, maybe we would have had to go with a lot more states. But if something like this comes where if this is okay or this is okay or both are okay, now you have maybe an idea how you could go around. So that was last week. Now we want to focus on new ideas, starting with regular expression. So we've already maybe covered regular expression a bit in the past here and there. It's things like this. So say you have a star, and this is basically a language. It's the language A star. And what are the strings that it accepts? So it's basically a set of strings. What are those strings? When you say A star, you're saying as many A's as you want. So that number of A's could be nothing. So it could be epsilon, or it could be 1, could be 2, could be 3, could be 100, as many as you want. When you say A star, as many as you want. If I had said A plus, however, this means at least one A. So the empty string doesn't work anymore. It's very similar, but like the empty string, you can't accept it. A plus means at least one A. So A, 2A, etc. At least one. Let me know if you've taken this symbol, the question mark. So these are like the 3 most common symbols, the star, the plus, or the question mark. Question mark is, think of it like you're asking a question. You either want an A or you don't. So it's either nothing with the empty string or just A. Second part, or second common things, usually we see something like A, B, star. This is saying you can choose either A or B as many times as you want to build your string. So I could choose nothing. Since as many as I want, I could say I don't want anything and I get the epsilon. Or just imagine every time you're going back and you're choosing what you want. Like I choose, for example, I can choose, hey, I want an A, then another one, then maybe some 3Bs, then an A, then 2Bs, then a bunch of As, etc. Every time like you're looping back and choosing whatever character you want to build your string. And you can have whatever sequence of A's and B's you can think of. Another way of writing this is like A or B star. This is the same thing. However, this is different. If I say something like A star or B, like the position of the star is very important. What is this saying? This is saying this or this. So by the way, this U symbol, it's like the logical or this or this. So I'm saying either A star or B. So either B alone, just a single character B, or a bunch of A's. So nothing, A, etc. This or this. If you wanted, for example, 1B and A's all around it, we would have done something like this. A star, B, A star. What does this say? Any number of A's that you want, followed by a B, followed by any number of A's that you want. So this is basically the strings that contain exactly one B. Okay. So the positioning are very important. Maybe one last idea before we actually start solving. AA star. I'm saying I can take as many AAs as I want. So it could be nothing, could be 2As, 4, 6, 8, etc. So it's like the even A's, which is similar to the first problem we ever solved. But it's very important, again, the positioning. So when I say something like A star, it's not the same as A star. This one, as we just mentioned, it's the even A. Can anybody guess what this is? When I say A followed by A star, what does this really tell me?
At least one A.
Exactly. So Nagam agrees with you. We're saying 1A followed by
two A's.
not at least 2A's. It's 1A, this first one, followed by any number of A's. So
The second A can be nothing.
yes, the other one can be nothing. However, this one is similar to saying at least 1A, or we've seen this before as well. It's like saying A plus. So we're comparing A plus with the even A's. So it's very like one slight change in the syntax could mean a completely different language. So we'll try to be careful with this as we go. But let's now try to solve these ones together. We'll do them one by one together. We have a bunch of regular expressions. For all of these, our language is simply just going to be A, B. This is our alphabet. Not our language, our alphabet. Language is different. Language is the set of strings. So let's just explain the first one and then we'll do it. What am I saying? I'll accept the string W that belongs to sigma star. So W could be any sequence of A's or B's. I'll accept it. However, there's a condition such that the length of W has to be odd. So this symbol means the length of W has to be odd, so it has to be 2k plus 1. Now, you can't really use W, Nagam. Even though you're kind of close, can you use something instead of W? Like W is your actual string. What is W? What could W be made up of? Okay, so if we focus on what Nagam is saying, I'll focus on this part. This is close. What this is saying is what? Even A, right? A star is even A, and here 1A, which together gives you an odd number of A's, which is really good. It's close. However, W could be whatever. W could be A's, could be B's, could be both of them together. With this, we're restricting it to only be A's. Can we slightly modify it to accept B's as well? What can we maybe replace A with? Aha, yes. I think I kind of understand what you're saying, Fatima. So Fatima, you're saying this, AB, AB followed by AB, AB star. Maybe I understand what you're trying to say, Fatima, but the way you're writing it, it could be wrong. This is literally what you're telling me. You're telling me AB followed by AB, followed by as many ABs as I want. Okay, so this is the language that you've written here. AB followed by AB, followed by as many ABs as I want. But I think what you're trying to say is something similar to what Nagam has mentioned, which is, okay, you want the even first. So this is even. I'll say A or B, followed by A or B. And I'll put all of this as a star. This gets you the even number of anything in your alphabet, in your language. If it's made up of A or B's, this is going to be it, and it's going to be even. However, to make it odd, I'll add that plus 1 at the beginning. with A or B. Let me know if you didn't get this part. I'm saying even, anything even, but with this +1 at the beginning to make it odd. It looks something like this. So this is the first part that gets you everything even, and then A or B at the beginning. I could have placed this at the end. That would have been also fine, either at the beginning or at the end, but of course not both. If I put it both, then it would have been even again. Okay. Nobody has a problem with this. We'll do the other one. Please ask me now because they're going to get slightly harder. If you don't get something, do ask now. The language W in sigma star, W has an odd number of A's. W has an odd number of A's. What could we do here? Okay, let's see the suggestion. So A, or B, followed by, oh, so all the star, followed by B star. So what is this saying? You're saying start with A, then choose either B, as many B's as I want, or two consecutive A's, as many B's as I want, or two consecutive A's, then followed by as many B's as I want. So there are a few problems with this suggestion. First of all, we're always forcing it to start with A. So there are some restrictions here. I'm forcing it to start with A. Another restriction, when I'm choosing the two A's, you're forcing them to be consecutive, which is not necessary. It's not necessary that they're consecutive, right? I could have something like this, A, B, B, A, B, B. They're not consecutive. Mariam, that's so with this suggestion, all right, you get me an even number, you get me, sorry, an odd number of A, but the problem, this only accepts strings that are made up of A's, right? This only accepts strings that are made up of A's. What about the B's as well? Johnny, I didn't understand why we are restricting to only A's and B's. I told you at the start, like your alphabet is AB. Okay, your alphabet is AB. So when you say W belongs to sigma star, that's like you're saying your string is made up of A's and B's, but there's a condition, odd number of A's. And very, very important, we're not saying no B's, we're just simply saying odd A's. All right. Nagam, I saw that you mentioned B star. Okay, if you put a B star at the beginning, you might have solved the problem of not forcing, but there's still an issue here in the middle. So let us focus slightly on what Nagam said. So B star, A, followed by AA or B star, and then B star. First of all, I don't think this B star is necessary here, Nagam, because you can already kind of get it from here, right? Like you can end it with B star from here instead of this one. So this one isn't necessary. Still the same answer with or without it. So if, assuming we want to go with this, it's very close, but the problem is this part. Always forcing it to be consecutive. Can we modify this somehow? By the way, there is no unique solution, right? So there could be multiple solutions to the same problem. So I'll think about it in a different way, okay? I'll say something like this. These are my two A's. Because again, we're focusing first on getting the even A, then we'll slap a +1 at the beginning or end. So these are my two A's. I don't want them to be consecutive. Okay, I'll put a B star between them. So whenever you choose those two A's, you can have as many B's as you want in the middle. But now I'm restricting it to either start or end with A. Okay, no problem. I'll put a B star here and a B star here. So basically what I'm saying is read two A's, but you can have whatever you want B's in the middle or start or end. So I'm not forcing anything. I'm not forcing it to start with A. I'm not forcing it to be that the A's are consecutive. Nothing. Right. Now, this might not look pretty, but we'll say then a big star on top of that. What is this saying? All right, you chose your two A's in whatever way you want. Now you can choose two A's as much as you want every time. So for example, say the first time I chose like this many B's, A, B, A, B. This is the first time I chose it. Three B's, A, B, A, B. Next time I loop, okay, this time I only want the two A's, so I'll just type in AA. Like the B stars could be nothing. Third time I loop, this time I want a B in the middle, so I'll say A, B, A. Third time I loop, I want B's at the end, so I'll say AA, B at the end. So with what I've written, the cool thing is I'm not forcing anything. So, but this is even A. How can I modify this? Any suggestion to make it odd now? If you're convinced that this is even, how can I make it odd?
Add an AB and outside
So to the right or to the left?
to the right.
Okay, so you want to add what? AB?
Mm.
But now you're forcing it to end with B. A quick fix?
Wouldn't we forcing it to end with B بس كنا حاطين كمان البي جوا؟
No, because this is B star. So it could be nothing. You could choose it to be nothing.
then B star.
Exactly. B star. So either B, so Nagam agrees with you, either B or nothing. And this is a solution. It works. And this thing here is actually very similar. It needs a slight adjustment, and the solution is actually very similar to this. So let's see the solution, and we'll see how they did this part slightly different right here. Again, this first part gets as many B's as you want to make sure if in case we want that, and then one A to make it odd. So they did the same strategy that we did to make it odd, which means this other part has to be even A. It has to be that. And how did they do it? It's very similar to what Nagam, I think, suggested, but the difference is they slapped a B star here in the middle. And why does that make it work? Well, think about it. Every time you're looping here, you can choose as many B's as you want. So like B, 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 B. And now you want your two A's, so you get this one, which is basically an A, as many B's as you want, then an A. Now when you loop back, you can either again choose as many B's as you want, so B, B, B. Then if now I want my A's, okay, I can choose this. I can choose the B star to be nothing, so it's just two A's, etc. And then I can, for example, choose two A's again, then this B as much as I want, etc. So it works as well. And if you think about it, it's again very similar to this part that we wrote. B star A, B star A, B star. It's very close, but it's kind of like, hey, they made it more, if you want, less messy. Like these two, they decided, hey, I'll put it here and it'll kind of have the same effect. This gets you your two A's, and the other part is what you use, so you're not forcing it to start or end with A. All right. There's no problem with this one. We'll keep going.
But I have a question. What did you say that union differs from not putting it?
Which part specifically?
لا،
here.
اليونيون usually إذا بحط اليونيون شو بتفرق إذا ما كانت موجودة؟
Okay, so like for example, A or B star
Yeah,
versus, for example, A B star.
AB. Yeah.
So this one is saying the sequence AB, you can repeat it as many times as you want. So AB, then I loop again, I choose AB. Every time I only have one choice, which is the string AB, I'm repeating it every time. But with this one, you have a choice. Every time you loop, you can either choose A or B. Okay, so first time I choose A, next time I choose A, next time I choose B, 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 A. Okay, so the
Okay.
difference is like the choice.
Yes.
Okay, part C. The language W such that W contains at least two A's or exactly two B's. At least two A's or exactly two B's. Remember, Nagam, that so let's break it down. They're saying here at least two A's, but you could have B's too. Like you could have B's. They're simply saying exactly two A's and as many B's as you want, or exactly two B's and like as many A's as you want. So like imagine something similar to what you did with the NFA at the beginning. Like they should specify it, but I'm telling you now, assume this or is inclusive. So if one condition is true, that's okay. If the other is true, that's okay. If both are true at the same time, that's also okay. Exactly, Nagam. In this case, I'm telling you, uh, both is also fine. And I'll again, a hint to break it down. Imagine there's a big OR, and here you'll solve one part, and here you'll solve the other part. Johnny, I'll focus. So let's do the exactly two B's because it's the easier part. And Johnny's close. Johnny's saying A star, BB, and then A star. Now, first of all, so this is exactly how you wrote it. As you wrote it, the brackets are not necessary because it only has A inside, so I'll remove them. And again, the star is only for the A. Okay, thank you. So it was a typo from Johnny. Johnny actually meant to have an A in the middle because as it is right now, I'm forcing the two B's to be consecutive, but they didn't mention that. So I could put an A star here and then a B. This is exactly the second part. I want exactly two B's. There they are, and you can have as many A's at the start, middle, or end. You're not forcing anything. All right, now let's do the maybe slightly harder one. W contains exactly two A's. Sorry, W contains at least two A's. Contains at least two A's. Is there a way maybe we can get in T2 and then do a trick, kind of like the odd?
A, B star, A,
What do you mean by AB star? Something like this?
A, then B that has a star,
Ah, A, B
and A.
star, and then A.
Mm.
Remember, they said at least two A's. So this, the way that you wrote it, you're specifically putting two A's and you're forcing it to start and end with A.
Then we can add a B star and an A that has a star.
So B star here is what you meant. The A star is kind of dangerous because you're saying any sequence, just any sequence of A's. Let's see what Omar is suggesting. B star, A, B star, A, B star. Okay, so far so good. So far we forced it to read at least two A's. Sorry, not so far we forced it correctly to read two A's and as many B's as we want all over. However, there's a problem with the end of what you wrote, Omar, which is when you then say A star, B star, Here you're forcing to first read the A's and then read the B's. Like you're forcing A's, then B's, but they could be alternating. They could be however you want. Nagam, we can't use B star, in which case? Remember, it's an or, Nagam. So when it's exactly two B's, it's only for this part. Now with the at least two A's, you can have here as many B's as you want. Close to Omar, very close. But instead of saying, so Omar is now saying, okay, instead of this, I want to write A star or B star. But now basically what you're saying, depending on if you put a bracket or not, it's completely different. If you leave it as it is, you're saying either this part or B star alone. But if you put a bracket, you're saying this part and either followed by A star or B star. So still not completely there. Yeah, that's what you want. So when Omar is saying all, I think Omar means the sigma. So we'll write it one last time. B star A, B star A. And here, I could add a B star, or right away, what Omar is saying, all star, which is either A or B star. Think about it. What did I just say? Do you want B's? Sure. You one A, then followed by B star, then another A. So far we've forced it to read two A's. And at the end, we're saying whatever you want. This is basically saying this is basically drawing the following NFA. I'm saying read as many B's as you want, then read an A, then read as many B's as you want, then read an A, and finally read whatever you want and accept. This is the exact same thing. Do you think it makes sense? Like you made sure you read two A's, and at the end, hey, whatever sequence you want is okay. And this is the answer. So this is the easier part, exactly two B's. And then there's this part, which is exactly as we wrote. Any question? Okay, great. And by the way, there's no unique solution. You see this DFA or this NFA? It would have been fine if I drew something like this. I could have also drew it like this. I could have said, okay, I'll read AB, then I'll read AB, then I'll read AB, and I'll accept here. I think this also would have been fine because why? I'm caring about forcing the two A's to be read, and I'm saying, hey, in between you can have whatever you want. Remember, with NFAs, as long as one route works, it's fine. And here we're making sure I read two A's. In between, you can have whatever you want. But part D. The language W belongs to sigma star. W ends in a double letter. So a double letter is either AA or BB. We're saying I want it to end in either AA or BB. What could I do? Do you guys agree with what Nagam is saying? I'll say A or B star. So anything, read anything, then end it with either an AA or a BB. Makes sense, right? Here you force it to end with AA or BB. And then before that, read whatever sequence you want. Yeah, straightforward. Part E, which is kind of like the complement of part D, right? I want the language such that W does not end in a double letter. Does not end in a double letter. How can I force it to not end in a double letter? What should I make it end with?
We try to make it end with A or B, and make sure that the part that's before the A and B is not the same as the A or B.
Okay,
Okay?
makes sense. I think what Maryam is saying, make it end with A or B, but make sure, for example, if it ends here with A, I should choose the B. And if it ends here with B, I should choose the A. Is that kind of what you're saying? Like if I have an A here, I shouldn't choose the A, I should choose the B.
Yes, exactly.
So maybe other than saying end with A or B, I could say something like this. Well, end with A, B, or BA. Wouldn't that make it easier? Because now if I end here, if I have an A here, I can choose whatever I want. Or if I have a B, I can choose whatever I want. Does anybody have a issue with what I just said? I'm saying make it end with AB or BA. Because like there's no real, so with this suggestion, there's no real way, like I can write an if else statement where, okay, you read an A, you choose this. You read a B, you choose this. I can't really code that. So instead, I'll make something more convenient to myself, which is, okay, this is what I want you to end with, either AB or BA. What do I make it read before? What should I have it read before? Thank you, Johnny. Anything, just anything. Hey, A or B star, read whatever you want. All I care about is that you do not end in a double letter. The way that I make sure it doesn't end in a double letter, well, end in AB or end in BA. That's the only way. Important, if I had said something like this, AB star, and make it end with A or B, the problem with this again, what if this was AAA? With this, I could choose an A, which ruins it. So I can't really force it here. We modify it like this. But not every solution is perfect. This solution that we have here also has a problem. What do you think it is? Aha, thank you very much, Nagam. Aren't we restricting the length of our sequence to be at least 2? We are. If I say end with A, B, or BA, I'm forcing it to end, the length is at least 2. So I do have some edge cases. What are they? How can I fix this with the edge cases?
Add a
Because
star to the
add
second part.
to this one?
Yes.
Not necessarily. This might ruin because if this is star, then this could be nothing. Then you're left with the sigma star, and you can end it with a double letter. Do you see it? If I add here a star,
Yes, yes.
it could disappear, and then exactly, I'm left with whatever I want. They're edge cases, right? Just write them in. They're not that many. Like so this is a general case if it's at least 2. Well, what about the other cases? If it's of size 1 or less, well, it could be an A, it could be a B, or it could be the empty string. All 3 of these are do not end in a double letter, so I should accept them. Again, Nagam, adding AB at the end, adding AB star is dangerous. Because adding AB, again, I can choose whatever I want. I can choose it to be a double letter. I would agree I could have ended it with A or B question mark. Maybe that. Because A or B question mark, what is it saying? Either A or B or nothing, which is basically the same thing as this. So this is the solution that we have. Just some edge cases. Why not? It happens. All right, last one. The language W contains exactly one double letter. Exactly one. Either AA or BB, not both. You can have AA, you can have BB, but you can't have them both at the same time because that would mean 2 double letters. And also, You can't have three consecutive letters. If you have A, this is considered two double letters because here you have AA and here you have AA. So that's also not acceptable. I'll give you a hint just to make it easier on ourselves. Let's try to solve it for AA. Because it's gonna be the same solution for BB, but like you flip all the letters. If I focus here on AA, so my string has exactly one double letter, which is AA. What should I write to the left and what should I write to the right to make sure it accepts what I want to accept? Any idea? Exactly, Johnny. I don't want any doubles. How could I get that? So I have here AA, and I don't want any doubles here. No doubles. How can I mimic this? What does it mean to not be doubles? Obviously, I don't want to use A or B star because here anything could happen. So something else. I have here AA, right? That means to my left, if there's going to be something right to the left of A, it should definitely be a B. Because if I have an A, it ruins everything. Nakam, what you wrote, you allow, first of all, it's all A's, so you allow multiple double letters. Johnny, use part E as an expression. Not necessarily. Johnny, the part E only says it does not end in a double letter. It doesn't say that it doesn't contain it. Part E only says it doesn't end with it, but it could have as many as you want at the beginning because of this A or B star. But okay, question. As we mentioned, I have here AA. If I'm building it to my left, I can't have A, I should have B, right? Because otherwise I'll have multiple letters, multiple double letters. Another one. Now to the left of B, what should I write? Can I write B? I can't, right? Because if I write B in here, I'm going to have another double letter. So the only thing to the left of B that I could put is A. Now ask that question again. What can I put to the left of this A? Can I put an A? No, I'll have another double letter, so it can only be a B. What can I put here? Can I put a B? No, I can only put an A. B, A, B, A. Do you see it? And Nagam, this similar to the A, you're allowing a sequence of B's, right? Like even if this question mark you take it to be nothing, you're left with the B star. You can have as many B's as you want. No worries. But what am I saying here with the A B A B? Well, simply I'm saying you should have A B star. Like A B A B A B, they have to be alternating because if they're not, you're gonna get a double letter, another double letter, which is what we don't want. But if AB at the left star, what should I have to the right? What am I allowed to put to the right of this A? Exactly, BA, 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 so BA star, the opposite. Almost done. The only issue here is what I'm forcing it to start and end with A, which is not necessarily correct. Can somebody offer one last fix and we're done? What maybe could I put here and put here that doesn't force me to end with A or start with A? Are you asking me if it's B star, Johnny, or are you saying B star question mark? Listen, I don't want B star because if I put B star, I'm allowed to have as many Bs as I want. It gets ruined. I either want one B or not. Exactly, Nagam. Either one B or not. One B or not. This is saying, okay, you can start with B if you want, or not, you can start with A. You can end with B if you want, or not, you can end with A. Okay. Focus with me only on this part. It's exactly what we wrote. AA. Then here you have the sequence AB, AB, AB. Here you have the sequence BA, BA, BA. So they're alternating. And this is basically the question mark. Either start with B or not. End with B or not. You can then read this on your own. It's the exact same thing, but the difference, you flip the B's with the A's. Because now you're focusing that it's BB in the middle. And everything else follows in the same way. Mhm. Moving on. Now I'll leave this to you to think about on your own. So if you remember this exercise, we solved this was the first ever exercise we solved where you had to do a DFA for this particular DF sequence. It was alternating odd A, even B. Now you want to give a regular expression for it. So just think about it like in your free time. You can send me an email if you're having troubles. Yeah, but maybe try to revise how we did the DFA. Maybe that'll help you to do the regular expression because it's not impossible, but it's kind of nice to think about. But I'll leave that with you. With what time we have left, I want to explain the idea of converting NFA to DFA. Now, I might need, to be honest, an extra 5 or 10 minutes. If for some reason you need to leave, that's okay. I'll try to repeat the idea next week and you can watch the recording. Okay, so now, new idea how we can convert from NFA to DFA. But before that, now that we kind of understand how regular expressions work, how can I do this part? So now they're telling us, give me an NFA for this. Give me an NFA for this language. How could I draw that now that I kind of know what's going on? Okay, so like this AA, I understand it as, okay, we want to read two A's. What does this part say, A or B star? What can it be translated to? So like, okay, this is here, okay, I read an A, and here, then I read another A. So this is the middle part. The beginning part, yes, Fatima, A, B star, like your string can start with as many A's or B's as you want. So like I loop back on myself, A or B, as much as I want. Then I read two A's. Now here I have a fork because the star is not outside. Very important, the star is actually inside. So I'm saying either end with BA or end with B star. So if I end with BA, that's kind of saying, okay, I read a B, then I read an A, and I accept. This is if I go with this route. What should I do if I go with the other route with B star? So from here, what should I do?
Change the accept state to the state on the left.
What do you mean? Do you want it to, we want it to go to some other state?
لا لا يعني ال accept state تنعمل قبل ال A.
This one?
Yeah, and you keep looping it until around yourself هيك.
Uh,
صح.
okay. The danger in this is what? Remember, I'm saying either end with BA or B star. If we do this, we give the option of ending in B star A, which is different, right? You read as many B's as you want and you end with A. That's not what they're saying. They're saying either end with BA or end with B star. Do you notice the difference? With this, you're saying read as many B's, then if you want, you can end with an A, which is different. I have a fork. Either read BA or I can read as many Bs as I want. Very different things. It's a fork. Either I go this route or I should go this route. Now, if you do it this way, you should make this one an accepting state. Since it's B star, it could be nothing, right? So it could be empty. Or I can read here a B and then read as many as I want. Okay. But now we reach the final idea for today, which is the actual conversion. So here we're given an NFA. How can we convert it to a DFA? Now you might have taken a method in class. I'm going to give you a slightly, in case you did, I'm going to give you a slightly different one that's probably more efficient. In order to do that, we first have to learn two ideas. One, or like two, say, functions. One is the move function. It takes two parameters, a set of states. So here we have like the states Q1, Q2, Q3. I can say, for example, it has the state 1. And I have to say on which transition does it want to move. So I could say something like small a. So the state 1 on transition A, where does it go to? Well, this is 1. It has two outgoing transitions, to Q2 and to Q3. This is the only A existing, so 1 goes to 3 on the transition A. So this just gives me the set of states, which is just 3. It could be multiple states. So I could ask, hey, where does 1, 2 go on A? Well, 1, as we saw, goes to 3. Well, where does 2 go to on A? 2 goes to 1, and it also goes to 3. I'm not going to write 3 again since we already wrote it. Sets are, there's no repetition in sets. So we'll just say it goes to 1. Okay, so that's one idea. The other idea is epsilon closure, which basically means where can your set go to on epsilon? It's similar to the move, but slightly different. So if I say sigma closure of 1, like just the state 1, step 1, you have to write all your states. So I only have 1, I write it as it is in here. Then you ask the question, where does 1 go to on epsilon? Well, 1 goes to 2 on epsilon, and it goes to 3 on epsilon as well. So it goes to 2 and to 3. However, now for here it's done, but say Q3 also on epsilon goes to some other state, Q4. And I have to ask this question, sigma closure of, say, 1, 2, where does that go to? Again, first thing we do is we write all the current states, which are 1, 2. Now for each of them, we ask, where do you go to on epsilon? So 1, like before, 1 goes to 2 and to 3. 2 is already there, so we just add in 3. Where does 2 go to? 2 doesn't have any epsilon transitions going out, so nothing. And this is the difference. If you added new states, you have to keep going. So now, since 3, we added it. Now you have to ask, well, where does 3 go to on epsilon? 3 goes to 4. And if 4 goes somewhere, we keep going. You ask, where does 4 go to? In this case, 4 doesn't go anywhere. So again, sigma closure of some set, you write all the elements, then each of them you keep asking, where do I go to on epsilon? And if a new state goes somewhere on epsilon, you keep going, you keep adding it. Unlike move, which is just one step, and you don't put them. So just 1 right away, it goes to 3. Okay. Right. Let's actually now use these to solve our problem. Again, the big idea here is we're trying to make an NFA out of a DFA, because if you remember, we kind of said that they're equivalent, or that they both have the same strength in terms of what languages can they accept. Okay. Now there's a reason why this method I'm about to show you works. there's a proof and whatever, but for now we're going to actually focus just on the implementation, on the how, on the steps of it, rather than the actual why it works. So step one, I want to do this. Sigma closure of starting state. So step one is always you do the sigma closure of what your starting state is, which in this case is just the set one. And if you remember, with sigma closure, first you write everything that's already there. In this case, it's just one. Then you ask, where does one go to on epsilon? One goes to two, and it goes to three. So you add them. We can keep checking 2 and 3, but we already listed all the sets. And what we do here is very important. I'm going to name this A. And basically what this is, in the DFA that I'm creating, I'm going to have some state called A. In the DFA, we're converting from NFA to DFA. So there's going to be some state called A, which is basically the combination of the states 1, 2, 3. Step 2, since I have the state A, what are the transitions of A? I have to find the outgoing transitions of A. So where does A go to on small a, small b, small c? You don't have to name it big A, by the way. You can name it whatever you want, like X, Y, Z, whatever. All right, so move big A on small a. Somebody help me out. Where does it go to? So 1, 2, 3, where do they go to on A? See, 1 goes to 3, and that's it. 2 goes to both 1 and 3. 3 doesn't go anywhere. So this is basically it, 3, 1. Exactly, Nagan, thank you. However, this isn't the complete step. When we want to find the outgoing transitions, what we should actually do is the sigma closure of move A. So it's actually the sigma closure of the move. So where does 3, 1 go to on with epsilon closure? Since 1 is there, we already saw from this part that 1 goes everywhere. So it's just going to be 1, 2, 3. And this is, we've already seen the sequence before, it's A. Basically what we're saying, in your DFA, the state A is going to loop on itself on the transition A. We keep going. Sigma closure of move A on B this time. We have to go through all the transitions. So it's sigma closure of where does A go to on small b. So where do 1, 2, 3 go on B? 1 doesn't go anywhere. 3 doesn't have any outgoing, so it's really asking only 2. 2 goes to 1, exactly, Naham. So it's the sigma closure of 1. But again, the sigma closure of 1 in this question is just simply everything. 1, 2, 3. Again, we're saying basically the state A is going to loop on itself on B. Last one for this state, sigma closure move A on C, which is the sigma closure of, so 1 goes to 2, 3 doesn't go anywhere, 2 goes to 3, exactly, Naham. And since 2 and 3 don't have any outgoing sigma transitions, it simply stays as it is, 2, 3. And we now have to name this B since it's a new sequence of states that we haven't seen before. So it's a new sequence of states. I haven't seen 2, 3 before, I have to now name it B. And since I have a new state, I have to keep going. I have to now repeat the same steps, but now I find the outgoing transitions for B. Okay, let's Buckle up. Sigma closure of move A on B. Uh, of move, my bad. Of move the state B on this transition A. It's probably not a bad idea to name them maybe something other than the actual transitions so you don't get confused. But where does 2, 3 go on A? So it's since 3 again doesn't have any outgoing, we're just gonna focus on 2, and Nagam is tell us it goes to 3 and it also goes to 1, right? So 2 has two. The state 2 has 2 outgoing transitions. It goes to 1, goes to 3. Again, the 1 is inside, so this is basically 1, 2, 3 with the sigma closure. It's A, which means you have some state B. A goes to that state on C, as we saw before, and B goes back to that state A on small a. Sigma closure. Let's move B on small b. I think it's only 1 in this case, which gives us 1, 2, 3. So this is gonna be A again. So I loop back on A and then B. Last one, sigma closure. B on C. So it's the sigma closure of, well, where does really 2 go? It goes to 3, and 3 doesn't go anywhere. So we're left with this. 3 doesn't have any outgoing transitions, so we're left with 3, which unfortunately means it's a new sequence of characters. So we're not done. Now you might ask me, when will I stop? When will this be over? Once you finish the sequences, the transitions, and you don't get a new state, you don't get a new sequence of characters, that's when you stop. That means, hey, there's no more new states, so I've really finished. But don't worry, this last part is actually gonna be pretty quick. This last part is not annoying, because if you look at it, part 4, find out of C. C is only made up of 3, and 3 doesn't have any outgoing transitions at all, so it's all going to be the same thing. If I say sigma closure of move C on the letter A, or on the transition A, well, where does 3 go to? Where does 3 go to on A? Doesn't go anywhere. I don't have any outgoing transitions. So it's the sigma closure of the it's of the empty set. I don't have any. 3 doesn't go anywhere on A. So it's as if I'm saying the sigma closure of phi, which gives you phi, like the trap. And if you do the same thing for B, it's going to get you phi. Same thing for C. It's going to also get you phi. Because 3C, which is the state C, which is only made up of 3, it doesn't go anywhere. And we're kind of done. Like once you reach the trap, that's it. Like the trap just loops on itself. Because if we try to do the same thing for the trap, well, the trap doesn't have anything. So the move will be nothing, and then again, the sigma closure will be nothing. So hooray, we're done. All that's left is maybe let's draw what we have. So again, we got the states A, B, C, and the trap. If I remember, A loops on itself on AB. Again, how do you do this? Well, just read what you've done. We're saying that A on small a goes to A on small b goes to A on small c goes to B. The transitions are right there, we just have to fill them. So this goes here. B on A and B, they go back to A. If we did a C, we actually go to the state C. Yeah, whoa, it's pretty cool. And then finally C on ABC, it just goes to the trap state, and of course the trap's gonna loop itself. Almost actually done. Two things are missing, your start state and your accepting states. Now the start state is just gonna be A, right? Because when we did the sigma closure at the beginning of the starting state, it gave us the new starting state in our DFA. But what about the accepting states? First of all, we stop when there is no new sequence of states, which is what we did when in part 4. Then what are the accepting states? They will be the states that contain, okay, so it's actually the states in the NFA that contain an accepting state from the DFA will be accepting. So what I'm saying is, if these states contain an accepting from the DFA, they're going to be accepting as well. And if you focus, the accepting state before was 3. A has a 3. B has a 3. And even C is just made up of 3. So all of them are accepting. A is accepting, B is accepting, and C is accepting. The only thing that's not accepting is the drop. Okay. Ah. I think, yeah, this is mainly it. Now, if you want to try and practice maybe for next time, you can convert the NFA that we did in the first part to what we did. So now the way that we did it, it didn't have any epsilon transitions. So it's kind of easier. You're kind of just doing it for the moves. So you can try to do that one. But the nice thing about this method is what? With the other method, you have to do 2 power n, right? And then figure out all the transitions. So in this case, if you have 3 states, you're going to get 8 possible states. And since in our case, at the end, we ended up with just 4, that means all you really need is 4 states. So 4 of these are going to be non-reaching. Like you write all the possibilities. Like you'll have 1, 2, 3. You'll have 1, 2. You'll have 2, 3, etc. 1, 3. You'll have each one on its own. So 1, 2, 3. This is like the older method. Then you'll have the phi. 4 of these states are not going to be reachable. But with this other method, you only write the states that you care about, only the ones that you actually ever reach. Because at every state, you're checking the outgoing transitions. So of course, they're only going to be the reachable. If you have any questions, you can let me know now.
I have a question.
Is it for today, or like I think you sent me a message, right, that you had some other questions?
Yes,
For today or for something else?
the last recitation.
Okay, no. If anybody has any questions for this recitation, ask me now. Otherwise, we'll like it's over, and yeah, no problem. Nagam and Fatima. Okay, so that was it for this one. Now, if anybody has any questions for previous recitations, you can start asking.